Hey everyone. If you've been keeping up with what's happening in space right now, you need to hear this. Something just passed closer to the sun than we've ever seen before, and what happened on October 29th has scientists absolutely stunned. We're talking about Atlas, an object that's breaking every rule we thought we knew about how things move through space. The ALMA telescope caught something that shouldn't be possible. When they tracked Atlas during its closest approach to the sun, they found it sitting 4 arcseconds away from where every calculation said it should be. Now, I know that might not sound like much, but in the precision world of orbital mechanics, that's enormous. Something was pushing or pulling Atlas off course, and it wasn't gravity. This is what scientists call non-gravitational acceleration, meaning some force we can't fully explain was acting on this thing. And here's where it gets even stranger. 3 different solar observatories, Stereo, SOHO, and GO-19, all captured the same phenomenon. Atlas didn't just brighten as it approached the Sunday. It blazed brighter than any comet we've ever documented, and turned blue. Not just any blue, but bluer than the sun itself. Think about that for a second. An object reflecting or emitting light that's somehow bluer than the star it's flying past. This is now officially the 9th documented anomaly surrounding this object, and we're rapidly approaching a moment that could give us a 10th. Here's the critical piece that changes everything. If Atlas were behaving like a normal comet with this kind of acceleration, physics tells us it would have had to shed at least 15% of its total mass. We're talking about more than 5 billion tons of material that should be floating around it in a massive debris cloud. But here's the thing that has Loeb and other top researchers paying close attention. On December 19th, just weeks away now, Atlas makes its closest pass to Earth. If all that material really ejected into space, there's no way our telescopes won't spot it. None. But if we look and find nothing, if there's no debris cloud where physics says there absolutely must be one, then we're staring at something that accelerates through space without losing mass, and that would shatter our entire understanding of how these objects work. Before we dive deeper into this story, make sure you hit subscribe and turn on the bell so you don't miss the next video. Okay, now let's get back to it. Now, for anyone just tuning into this story, or anyone who wants to understand why this matters so much, we need to talk about what makes Atlas completely different from anything else we've encountered out there. This isn't just another space rock passing through our neighborhood. Atlas is the 3rd confirmed interstellar object ever detected, joining Oumuamua from 2017 and Comet Borisov from 2019. But calling them similar is like comparing a mouse to an elephant. The scale here is almost incomprehensible. Atlas is 1,000,000 times more massive than Oumuamua. Let me put that in perspective. If Oumuamua were the size of a ping pong ball sitting in your hand, Atlas would be a multi-story building towering over you. And it's not just mass. Atlas is also 1,000 times larger than Borisov, which was already considered substantial. But here's where things get statistically bizarre. In nature, there's usually a trade-off between size and speed. Bigger objects tend to move slower because of energy conservation principles. It's why massive cargo ships cruise while speedboats zip around. Yet Atlas is both gigantic and fast, moving quicker than both previous interstellar visitors, despite being exponentially larger. When astronomers ran the numbers on this combination, they found the probability of an object naturally being both this massive and this fast is less than 0.1%. That's not just rare. That's approaching the edge of statistical impossibility. And this is just the beginning of why Atlas has the scientific community in heated debate. Every conventional model we have for how interstellar objects should behave is being challenged by what we're observing, and the size-speed paradox is only the first major red flag that something very unusual is happening here. So let's walk through exactly what makes Atlas so unprecedented. Because when you see all 9 anomalies laid out together, the picture becomes incredibly compelling. The first anomaly is the trajectory itself. Atlas is moving in what's called a retrograde orbit, meaning it's going opposite to the direction planets move around the Sunday. That alone isn't necessarily strange. Plenty of comets do this. But Atlas's retrograde path is aligned within just 5 degrees of the solar system's ecliptic plane, the flat disk where all the planets orbit. Imagine someone blindfolded throwing a basketball backwards through a hoop from across the court and having it swish perfectly through the center. The math says this happens naturally only 0.2% of the time. Then there's the solar jet, and this one's a game changer. Between July and August, Atlas developed something never documented before. a jet of material pointing directly toward the Sunday. Every single comet we've ever studied does the exact opposite. When ice vaporizes from solar heat, the solar wind pushes that material away, creating tails that always point away from the Sunday. It's fundamental physics that's been observed thousands of times. Atlas said no thanks and shot material toward the sun instead. The third anomaly we touched on, that impossible size and speed combination with less than 0.1% probability. Fourth is the timing, and this is statistically the most mind-bending. Atlas arrived at precisely the right moment to pass within tens of millions of kilometers of Mars, Venus, and Jupiter, while simultaneously being completely invisible from Earth during its closest solar approach. The probability of this alignment happening by chance? 0.005%, 5 in 100,000. Picture throwing 3 darts at once, hitting 3 separate bullseyes, while a fourth person turns away at the exact right second. That's the level of precision we're talking about. The fifth anomaly comes from spectroscopic analysis of what Atlas is actually made of. Natural comets have predictable ratios of metals that reflect the primordial composition of wherever they formed. Atlas has a nickel to iron ratio that doesn't match any known comet. Even more bizarre, this ratio resembles the metallic alloys we manufacture industrially here on Earth. The strangeness doesn't stop there. Anomaly 6 is the water content, or rather the shocking lack of it. Comets are supposed to be dirty snowballs, mostly water ice with some rock mixed in. Atlas is only 4% water by mass. Finding a comet with that little water is like discovering an iceberg that's 96% rock. It fundamentally challenges what we even classify as a comet. The seventh anomaly involves polarization, which is how light waves orient themselves when bouncing off surfaces. Atlas shows extreme negative polarization that's never been observed in any other comet, including Borisov, which we know for certain is a natural object. It's as if Atlas is twisting light in ways that known natural materials simply don't do. Anomaly 8 connects to one of the most famous moments in the search for extraterrestrial intelligence. In 1977, the Big Ear radio telescope detected the WOW signal, a radio transmission so unusual that the astronomer who found it literally wrote "wow" on the printout. It remains the strongest candidate for an alien signal ever captured. Atlas is traveling from a direction that aligns within 9 degrees of where that signal originated. In the vast expanse of interstellar space, having 2 anomalies point back to nearly the same cosmic address is like 2 cars passing through the same remote intersection just minutes apart. And the 9th anomaly is what we opened with, that impossible blue brightness near perihelion that exceeds anything normal cometary materials should be capable of producing. 9 separate anomalies, each one individually strange, all present in a single object. This is why scientists like Loeb are saying we need to seriously examine every possibility, even the ones that sound like science fiction. And now, we're approaching the moment of truth that could either explain some of this or deepen the mystery even further. The non-gravitational acceleration detected by ALMA creates a testable prediction. If Atlas behaved like any normal comet experiencing that kind of force, it had to eject more than 5 billion tons of material into space. That's not speculation, that's what the physics demands. And if that happened, there should be a massive debris cloud surrounding the object that would be impossible to miss when Atlas makes its closest approach to Earth on December 19th. This is what makes the next few weeks so critical. We're not talking about vague predictions or distant maybes. We have a clear, binary test coming up. Either we detect the debris cloud and confirm at least one aspect of normal cometary behavior, or we don't find it, and we're left with a 10th anomaly, an object that accelerates without shedding mass, which violates everything we understand about comet physics. Loeb, who's one of the world's leading astrophysicists and chairs Harvard's astronomy department, has been carefully documenting all of this. He's not saying it's definitely aliens. What he is saying is that when you have data that consistently refuses to fit existing theories, the scientific method requires you to consider new hypotheses, even uncomfortable ones. That's how science actually progresses. Galileo was mocked for suggesting Earth orbited the Sunday. Einstein faced ridicule for relativity. The pattern throughout history shows that major breakthroughs often come from questioning what everyone assumes must be true. The controversy around Loeb's approach is interesting in itself. Critics say he's being too speculative, jumping to extraordinary conclusions. But Loeb's response is that he's simply following the data wherever it leads and calculating probabilities based on what we observe. If Atlas turns out to be something artificial or technological, we're not just talking about discovering life beyond Earth. We're talking about detecting evidence of a civilization advanced enough to send objects across the interstellar void. But even if the final answer is natural, some new category of cosmic object we've never encountered before, that discovery alone would be revolutionary. It would mean the universe has phenomena we never predicted, expanding our understanding of what's possible out there. Either way, we're looking at a monumental moment in scientific history. So here we are, living through what could be one of the most significant discoveries humanity has ever made, and we don't have to wait decades for answers. The December observations are happening in just weeks. When Atlas makes that close pass by Earth, our best telescopes will be watching, and we'll finally get definitive data on multiple anomalies. If we don't find that debris cloud, we've got our 10th anomaly staring us in the face. Undeniable proof that something about Atlas doesn't fit our models. If we do find it, great. We've answered one question, but we're still left with 8 other anomalies that need explaining. What's really hitting me about all this is that regardless of how it turns out, Atlas has already changed everything. It's forced the scientific community to confront the possibility that our assumptions about what's normal in the universe might be far too limited. We've gone from thinking interstellar objects are rare curiosities to realizing they might be common, and some of them might be very, very strange. The most exciting part is we're not speculating about some distant future revelation. The next few months are going to give us concrete, observational data that will move this from mystery into understanding. Whether Atlas is an unknown natural phenomenon, technology from an origin we can't yet imagine, or something we don't even have concepts for yet, it's pushing us to ask bigger questions about our place in the cosmos. So what do you think is really going on here? Is this the strangest natural object we've ever encountered? Or are we looking at something that was made rather than born? Drop your thoughts in the comments, because I want to hear what you're thinking. And if you want to stay updated on every development as December approaches and we get those crucial observations, make sure you're subscribed because this story is far from over. The answers are coming, and they're coming soon. I'll see you in the next one.